How are you doing, everyone? My name is Michael Weintraub. This is my Everyday Video Chemistry 7. And the observation prompts for this experiment, we did a little baking, some real baking in a microwave. So before putting the batter in the microwave, were there any bubbles? There were not any bubbles before putting the batter into the microwave. After I turned on the microwave, I did see some bubbles form. The batter rose and carbon dioxide gas was being released through the bubbles. When I turned the microwave off, the cake did stay the same height. It did drop a little bit over a little bit of time, but I think that was pretty minute. And I think it did start to fall back because the carbon dioxide gas, the last of it that was heated up or excited, was released. When I cut into that cake that I made, there were small holes, and that was from the carbon dioxide that was formed or created that had yet to escape from the cake batter yet. Is that all of them? Yeah, so the reflection prompt is, how did the microwave heat up the batter? Well, the microwave heats up the batter just like any food using its electromagnetic radiation. That radiation will just cause movement in the water molecules and atoms, and that causes heat, which will cause heat. Why did the baking soda form CO2 gas when it was heated up? Well, the baking powder contains baking soda and some form of acid. So when it's mixed with a liquid, which we use milk for this experiment, that acid will react with the base, which is the baking soda, which will then mix, and that will release the carbon dioxide gas. Why did the batter rise when we were heating it, then fall back down for a bit when the microwave stopped? So the batter rose because the carbon dioxide gas was being actively created and formed during the baking process. The gas got trapped, and that created air pockets, causing the batter to rise. When the microwave stopped heating up or stopped providing heat, the gas began to escape, causing the batter to fall back down a bit, and that because there's no more heat being provided, the carbon dioxide gas that formed and that had yet to escape was left in air pockets. Yeah. And so some real life examples, obviously baking, but because we did that for this experiment, I didn't think that would count. So I decided something to talk about near and dear to some of my family members' hearts: gluten intolerance. Baking powder is a very common use for gluten-free baking as a substitute for flour and a couple other baked goods. And so the whole chemistry behind this experiment shows how people with gluten intolerance, like my sister, like my mother, not me, can enjoy baked goods without suffering from their gluten intolerances and allergies. Thank you. Have a good day.